Alright, let's look at the practice exam 1, problem number 6. Right, so for the curves, f of x, so this is a quadratic function, so you're going to see a parabola. And with the negative leading coefficient means that it's a parabola facing down. Right, and g of x is just a linear function, so it's going to be a line. So ballpark picture of the region is going to be, so you have parabola facing down, then you have a straight line going through it, right? So the region we're looking at is this region right here, right? So it's bounded above by the parabola, bounded below by the straight line, right? So let's find the 2 points of intersection of these curves, right? So we just need to set them equal to each other. So let's see, x plus 2. So I'm going to set x plus 2 is equal to negative x squared plus 4x plus 2. Right? So since the both sides has 2 in it, so by subtracting 2 from both sides, so you can cancel 2. Right, then I'm going to actually put everyone on the left hand side, so I'm going to add x squared to get rid of this and subtract to 4x. Right, so you get, let's see, you have x squared on the right, and subtract 4x from x, so it's negative 3x, and everyone's gone on the right hand side, you get that. Alright, then we can just factor that out. So just pull out the x's in common. So you have x minus 3. That's equal to 0. So therefore, we found the x coordinates of the points of intersection. So it's either 0, or we can set that guy equal to 0, so it's 3. Alright. So, but point of intersection would be, so points of intersection is, right, so x coordinate, we found that to be 0, and also 3. Alright, and you can use either function, but I like the second function better since it's simpler. So if you plug in 0, 0 plus 2 is 2. So that's the corresponding y coordinate. 3 plus 2 is 5 to get that. Right, so those are the 2 points of intersection. Alright, now we can set up the integral for the area of that region. So area A is going to be, right, so this point has a coordinate, x coordinate 0, so it's going to start from 0, and the other point is obviously coordinate is going to be 3, right? Then top one is the parabola, so I have to write this guy first. Top curve minus the bottom curve, which is x plus 2. Right, so this is the integral. Right, so we can simplify this. First, 2 minus 2 cancel out. Then this simplifies to, this is going to be equal to integral from 0 to 3. Then you have a negative x squared. Right, then you have a 4x minus x, so it's a plus 3x. Right? Then all you have to do is find the antiderivative. So antiderivative is going to be negative x cubed over 3 plus 3 x squared and over 2. Right? Then it goes from 0 to 3. Right? Then I'm gonna go down here. There's more room here. Right, plug in 3. So one of the 3 cancel out, so it's going to be 3 squared, so negative 9. Right? and plug in 3, so that's going to be 3 times 9, 27 over 2. So plus 27 over 2, right? And so we have that, and then minus, and if you plug in 0, it's actually, that's 0 and that's 0, so it's 0 anyway. So actually I'm not gonna write that down, so I'm gonna just say I'm gonna just erase it. Right, erase this guy. Alright, so this is going to be it. So this is going to be, alright, 9 is 18 over 2. So if you subtract the 18 from 27, so that would be 9 over 2. Right? So this is the area of this region bounded by this parabola and a straight line. Right? That's it. I hope that this was clear.